guys, today we'll be talking about how to find the equation of a tangent on the graph. So we've been doing calculus all along and we already know how to find the derivative of a function, but we didn't really talk about what is that derivative first of all. So we are given this function, it is drawn obviously, then given the equation which is f of x is equal to x squared minus 4x minus 5. Say find the equation, how to find the equation of a function. First of all, let us find the first prime of this function, which is the derivative. F prime of x is equivalent to what? Is equivalent to 2 multiplied by x to give us 2x minus what? 4. That is the derivative of the function. But what is really the derivative? What we are saying is that the derivative of a function is the what? Is the gradient of a tangent at any point on the graph in terms of x. We know if we are to draw a tangent on the graph, a tangent is a line that touches our graph only once. If you can see, I drawn 2 tangents on the graph. We can draw a tangent at any point on the graph. So I assume the decreasing tangent touches the graph at what intersects with the graph at 5 and 0, and the decreasing one intersect with the graph at -1 and 0. It means those 2 tangents intersect with the graphs at the x-intercept of the graph. So they can say find the equation of those 2 tangents. How are we going to find the equation of those 2 tangents? Since are the straight lines which are diagonal, we're gonna say the equation of those 2 tangents. Let me start with the one that intersect at 5 and 0. So what I know is that the equation is gonna be y is equivalent to mx plus what? Plus c. Because this is the equation of a linear function, which is straight line. Also remember, a tangent is a straight line which can be defined by that equation. So, but how are we going to find the gradient if we only have one point on the graph, which is the point of contact and the point of contact of the tangent and the graph? So what you're simply saying is that the first derivative of the function represents the gradient of its function of the tangent at any point on the graph in terms of x. So in order to find the gradient of a tangent at this point, which is 5 and 0, so what you're going to do is that you're going to say, okay, since you have f prime of x, which is equal to 2x minus 4, we said f prime of x is the tangent of what is a gradient of a tangent. So to find the gradient of a tangent at a specific point, you have to know the point of contact of the tangent and the graph. So I already know the tangent which I'm looking for, which is the one that intersects with the graph at 5 and 0. So wherever I see x, because the point of contact is 5 and 0, so I'm just going to take this x and substitute on the equation. I'm going to say at x is equivalent to what? Is equivalent to 5. I took the x value at a point of contact. Then I will say f prime of what? F prime of 5. Wherever I see x, I substitute to 5 is equivalent to 2 into 5 minus 4. Then what do I get? What I will get the gradient of the what? Of the tangent. Remember, I said f prime of x represents the gradient of a tangent. But in order to find the gradient, the specific value or the absolute value at a certain point, so you have to know the point of contact for that tangent and the graph. So I originate the point of contact, which is 5 and 0. So it means the gradient now we're just gonna press our calculator 2 multiplied by 5 minus 4 to give us what? 6. So it means the gradient of the tangent at that point is 6. Now I can say I have y is equivalent to 6x plus c because I already know the gradient. But now what about the y value, which is the value of c, the x-intercept? So to get the value of c, I need a point that exists on the tangent. So, but the only point I only have the point of contact for the tangent and the graph. So I will use that point of contact as the whole of the point to find the value of c. I will say at the point of contact, which is 5 and what? And 0. So I'm going to substitute this point on the graph so that I can find the value of c. 0 is equivalent to 6 into 5 plus what? Plus c. Then, to solve for the value of c, I will say 6 multiplied by 5 to give me 30. Then 30, take it to the other side to be negative 30. It means the value of c is negative 30. We can all agree with that. So it means the equation of the tangent at that point, it's y is equivalent to 6x minus 30. That's how we find the equation of a tangent at a certain point. So let me do another example with the tangent that intersects with the graph at -1 and 0. How can we find the equation of that tangent? What I know, guys, is that the equation of the tangent will be y is equal to what? Mx plus c, since it's the straight line. So to find the equation of the tangent that intersects with the graph at -1 and 0, what I will do, I will just have to start with the gradient. I said we're gonna look for the f prime of x, which I already have, which is equivalent to 2x minus 4. This thing f prime of x of the derivative of a function represents the gradient of a tangent at any point on the graph in terms of x. But I need the gradient at the what? At the point where the graph intersects with the tangent at -1 and 0. So I'm going to just take the x value, which is -1, and substitute on the first derivative. I'm going to say at x is equivalent to -1. So it means now f prime of -1 is equivalent to 2 into -1 minus 4. There we go. So this is how we get the gradient of a tangent at a certain point. So m is equivalent to what? -2 multiplied by -1 to give me -2. -2 minus 4 to give me -6. It means the gradient of a tangent at that point now it's -6. I have the equation as -6x plus what? Plus c. What is left now is the value of what? The value of c. It means now I will use the point of contact. As I already said, the point of contact, it's gonna help me to find the value of c. When I say at point what? -1 and 0. So wherever I see x, I'm just gonna substitute -1 and y as 0. So I have 0 is equivalent to -6 into -1 plus c. 0 is equivalent to what? What is -6 multiplied by -1? It's gonna give me obviously +6, then plus c. Then take 6 to the other side to change sign to be negative. So I'm gonna have c as what? As -6 also. So it means the equation of that tangent, if I have to write it somewhere here, it's gonna be y is equivalent to -6 minus 6. That's how, guys, -6x, sorry, -6x minus 6. That's how we find the equation of a tangent at a certain point on the graph. So I believe, guys, you do understand what I was saying, what I was explaining today. So just to cheer you up, let us say you're given a point on the graph at a certain point. I'm just gonna draw it maybe in red. That's a point now. Then we have a tangent that passes through that point. A tangent. What are the coordinates of that point? The coordinates of that point are -1. It's not gonna be -1. It's just gonna be 1, negative. Okay. I have 1 and -8. So I would like you guys to go on and do that question just to see if you understand what I was saying. So you can pause the video and try to do this question and then come back and do the corrections. So what I know, if I need the equation of a tangent at that point with the coordinates 1 and -8, The first thing I'm just gonna need the equation, which is f of x is equivalent to what? To x squared minus 4x minus 5. So now we're gonna say f prime of x is equivalent to 2x minus 4 because they wanted the equation of a tangent and the what? They need the equation of a tangent on the graph. So we know we have to find the first derivative. To find the first derivative, you know, guys, you take the power and multiply with the coefficient of x and subtract 1 from the power. We do the same thing for each and every term, but the derivative of a constant number, which is negative 5, is 0. So now we're gonna say f prime of what? F prime of positive 1, because the x value at that point is positive 1, is equivalent to 2 into what? Into 1 minus 4. So what do we get when we press our calculator? We get m is equivalent to what? To negative 2. So it means the gradient at that point is negative 2. Now we need to find the y, the y-intercept, which is the value of c, because we know the equation is y is equivalent to negative 2x now plus c. We already know the gradient because we found it. We need the point of contact to find the what? The value of c. We are given that point, which is 1 and negative 8. So we're just going to say at what? At 1 and negative 8. Let us go on. Then wherever I see x, I'm just going to substitute 1 y as negative 8. So I have negative 8 is equivalent to negative 2 into 1 plus c. Then let us simplify. We have negative 8 is equivalent to negative 2 multiplied by 1 to give me negative 2 plus what? Plus c. So what do I get as the value of c? I take negative 2 to the other side to be positive. I'm going to have negative 8 plus 2, which is negative 6. It means y-intercept of that tangent is negative 6. So now let us write it down the equation since we found the value of c. It means y is equivalent to negative 2x minus what? 6 as the equation of the tangent that intersects the graph at the what? At y at x is equal to 1 and y is equal to negative 8. So that's how, guys, we find the equation of a tangent at any point on the graph. So first of all is that you have to find the gradient of the tangent. How do we find the gradient of a tangent? We look for the first derivative of that function, and we know that the first derivative represents the equation of a tangent on the graph in terms of x. But we can find the specific gradient at a certain point. So what we have to do, we have to know the point of contact at the tangent and the what and the graph. After finding the point of contact, we take the x value and substitute on the first derivative to find the value of the gradient. So now after finding the value of the gradient, we have to find the value of c. How are we going to find the value of c? We need the point of contact as a whole with x and y. So now after finding the point of contact, we just use the point of contact to get the value of c. Then after that, you get the equation of the gradient of a tangent at a certain point on the graph. That is the lesson for the today, guys. Thank you for watching this video.